On this episode of Pipeline Things, we talk Rise of the Machines, the T0s, T1000s, everything you need to know about machine learning and how it's taking over integrity. No, but in all seriousness, we talk with Cliff Maier on how machine learning is being used to improve SEC susceptibility models and help advance the state of predicting where to go look for SEC.
If you didn't read the paper, we got the Cliff Notes.
Oh my God, that was clever. Welcome to the PPIM edition of Pipeline Things. We continue on our journey of interesting papers that we are examining to look at. And today, our guest is Cliff Maier, and he's going to be talking about using machine learning to manage SEC data strategy and best practices. So while I do expect that we're going to have a phenomenal conversation around a hot topic, that paper title is lame.
But that shirt is not.
That shirt is fire.
That
You
shirt
pull off
is
pink quite
fire,
well.
bro.
I do
appreciate
agree with
that.
you.
Kudos to you.
I
for
can't
real.
pull off pink. That's true. Well
Thank
done.
you. Props to my wife and my daughter.
Yeah, my wife still isn't able to dress
but
me.
like
She's
you could have
trying.
done something like SEC or the machines taking over, SEC Rise of the Machines, playing off of Terminator.
Is this T1 or T2? Or T0?
Well,
Maybe T0?
Stay tuned. Yeah.
Is it going to melt down and take us over? Point is, I would like to work with you on future titles for your papers to make them
Oh my God.
more come out and punch people in the face, grab attention.
I would appreciate
So-
your input. Yeah.
Would you really?
Absolutely.
Okay, cool. And then you can help me with color schemes because I can't pull off pink, but clearly you can. So well done.
Thank you.
To our audience out there, you're going to have to look at the YouTube to get any of what we're talking about.
How are you not
um,
watching the YouTubes yet? Well, I guess it's easier to listen on
I mean,
Spotify.
all the cool
yeah,
kids
it makes
are.
Sense. It makes sense. It's
So-
easier to listen to.
Cliff, will you set the stage for us a little bit?
Give us
I
the
think
Cliff Notes.
We know a lot about SEC. We've covered that a couple of times. Audience, I'm going to assume that you're familiar with SEC. If not, we have past episodes on it. But tell us a little about who you are and how did
Yeah.
you get pulled into SEC?
Absolutely. I started my pipeline career about 25 years ago. I started working for CC Technologies and initially got into things like finite element analysis and then laboratory work, looking at corrosion experiments and then cracking experiments. Eventually went into pipeline integrity, doing fitness for service type assessments, and really developed an interest in the cracking threat. So working with the likes of John Beavers, got to learn quite a bit about stress corrosion cracking.
Yeah.
And then
Can I give you a fun fact?
absolutely.
I bet you less than 2/3 of our listeners know who John Beavers is.
I've heard the name.
Oh, there you go. There's
I know.
another
I know.
one.
I don't know him personally, but I've definitely heard the name.
He's well known within the industry and definitely very involved with NACE and other organizations. So very well respected in the
Another one of the
cracking world.
sages.
Do you
Just
think we could get him on the podcast? I'm sure. Keep going. Keep going. You're doing
Yeah,
great.
sorry,
Okay.
keep going. Yeah.
Yes. So roughly 5 years ago, saw an opportunity at TC Energy for the integrity management team. So they had an opportunity for me to be part of that team for stress corrosion cracking threat management. So
Yeah.
I jumped on that and been there ever since.
Cool.
Still in the same role.
Fantastic. So sidebar conversation. You served on the consultant side and the operator side.
Yes, I did.
Do you like the switch? It's been good for you?
It's a good switch. Yeah. Being on the operator side gives me different insights and different perspectives now. So it's nice to kind of see a whole picture.
Yeah,
Yeah.
but it does. So tell us a little bit about this paper, right? Because the subject of SEC has been out there for a while, right? We have various susceptibility models. So when I see that we're using machine learning to manage SEC, what are you guys trying to do? We're trying to just give me a picture.
What's the need? Why is it cool?
I mean, yeah, can't we just find 60%, find out where we have soil types and move on?
Well, SEC is a complex threat. There's a lot of complex factors that go into where the cracking develops and grows. So one of the assessment methods that we use at TC is stress corrosion cracking direct assessment.
Yeah.
So I know a lot of operators use that method. And in that method, we utilize excavation data to integrate with inline inspection data and so on, so we can.
Oh, y'all integrated with
understand.
inline inspection data, though, right? Y'all are like
Correct.
not pure DA where it's like guess and check. Guess here, we think it exists there. Go dig, it doesn't. Like y'all are actually integrating it with ILI data. I assume EMAT on cracks.
Not so much EMAT for
Okay.
for DA. If we have an option to
Okay.
run an EMAT tool,
Yeah.
we may choose that option instead of DA.
Okay, so you're
Yeah.
integrating other like MFL.
Correct.
Okay,
Yeah.
cool.
That's correct. So with DA, we typically are looking for conditions that are favorable for cracking to develop. So we're not actually chasing a specific crack anomaly that we know about.
Correct.
We're just looking for where all the factors coincide.
Yeah.
And so that's where the machine learning comes in, because we wanted to look at machine learning as a way to analyze our big database of dig information
Mhm.
and see what patterns we can identify in the dig data for where we find the cracking.
And that data set does include your inline inspection EMAT history.
Well, that does. Yes. Yes.
Can I ask, is it proprietary? When you say big data set, how big is big data set that you're feeding it here on excavation history?
It's hard to put a number to that,
More or
but
less than
we're-
1,000.
it would be more than 1,000.
More or less than 10,000.
It's probably a bit less than 10.
Somewhere
Ooh,
between
but
1
only
and
a bit
10,000.
less.
that's a good
Okay.
range.
That's
All
pretty
right.
good.
But
Gotcha.
we're talking in the data set we're specifically talking about here today. It's roughly probably 2,000 digs dating back to 2012.
Okay.
And these would cover a various array of reasons to dig. So we would have digs that are based on metal loss features, digs based on dents, and other reasons, not specifically just for cracking.
Got you. So you collected, or you've done these excavations over the last 20 years for a variety of reasons. You're taking all the variables and then feeding those into what you're calling a machine learning model to do what?
That's correct. So in terms of our SCCDA program, as I said, we conduct excavations where we think cracking is most likely to occur. Well, we use a scoring model for that. And in the scoring model, we use different data attributes such as topography, drainage characteristics, whether there's a dent present from a previous ILI, or so on. So when we look at the scoring model and select a dig site, it's oftentimes we find that there might be 2 or 3 locations that really seem like good candidates.
Yeah.
So unless we're digging multiple sites, it would be helpful to really distinguish a little bit better which site might be more appropriate, where we're more likely to find cracks.
Enter machine learning.
Enter machine learning. So machine learning, we think, can help us be a little smarter about finding those locations.
Right. So if what I'm hearing, and correct me if I'm wrong, right now you'll have not an arbitrary weighting system, but a weighting system of these factors in some form that was thought about. But we know these weighting systems are judgment based. Are you trying to find something smarter than your current weighting system to improve your dig locations? I'm trying to define machine learning in a simple concept for me.
Absolutely. That's absolutely right.
Gotcha.
So the machine learning will help us understand the relative importance of the different parameters.
So now these digs going back 20 years that you fed into this, one of the things that immediately stands out to me, and I'm just curious, how, every data set I assume did not have the same information pertinent to it.
That's true.
So that seems like that even be a challenge. Like I could see like, oh, great, we found SSC at this location. Fantastic. They didn't get information on X variable, right? How, whenever you're working with a data set like that, how did y'all compensate for the fact that you might have gaps in various data entries to the machine learning model?
Well, I think we try to minimize the gaps, obviously,
Sure.
but inevitably there are some gaps. So the type of model that is chosen will hopefully account for some of those gaps and do a good job of managing those. So that will shake out when we validate the different machine learning models.
So if we go back just a little bit, right? So back to why. You guys are in a DA program. You have to do excavations. You have data you're trying to render to understand which ones have a higher priority in establishing where to dig. So you have all these previous excavations. You have data. You guys are exploring machine learning to understand which parameters are better indicators for you to say, if I have this, this is likely where I will find a crack if a crack exists.
That's
as part
right.
of my DA program. Well, that sounds fun.
Absolutely.
What'd you learn?
We learned a lot. I guess the biggest thing we learned is that we validated this machine learning approach as a good proof of concept that
Yeah.
machine learning can be used for this purpose.
Nice.
We also learned that the machine learning is telling us a lot of things we already knew about stress corrosion cracking. So a lot of the same susceptibility factors that you would see from ASME B318S or the SEPA recommended practice document or the NACE document, they're all consistent. So the machine learning model just reinforces some of those things we already knew.
Well, you say that, but I want to help the audience understand. So Cliff, and this came straight from the presentation. Audience, if you weren't here, I'd encourage you to take a look at the paper. It kind of looks to me, real quick, that's 28 variables that y'all threw mud at the wall. That's kind of the initial variables you threw at the machine learning matrix look like mud on the wall. I mean, it's got things like years without CP, surface preparation. That's interesting.
Topography.
Even hard spots. I mean, things that make sense, but pressure cycling. I've never heard of anybody try to liken pressure cycling to stress corrosion cracking.
Depth of cover.
Yeah, I mean,
Ooh.
river crossings,
Yeah.
groundwater. Y'all kind of like threw the book at the machine to see what it would find, and then
We
it came
did.
back and told you, "Oh, here's what we do."
We did.
And that didn't surprise you that you didn't find anything like really, really new. None of the variables that threw back at you.
Initially, there's nothing obvious that jumps out as being surprising. So as we continue to evaluate the model, we may learn more things that maybe we didn't know before. So for example, there could be interrelationships between some of these parameters that may not be evident in some of the guidance documents that are out there.
Did you come back? I mean, like flex, like, see, us old guys, we developed this without all this fancy machine learning. We got the same
Yeah.
answers.
Well, we haven't gotten to like the
Go
top
talk to
5.
John Beavers, come back on you, give him the data, and John Beavers is like, "Yeah, see, I told you, you didn't need to do all that. It was
Yeah.
good enough what we had."
Exactly, yes.
I kind of want to start asking them about what they found from like which parameters are the most important.
Oh, I think that's a good thing to do. But
Wait,
what
I
we're
can't
actually
ask
gonna
before we
do-
take a break.
You can ask the question, and then I'll force the break since we're going to have this. Go ahead, ask the question.
What parameters did you find surfaced that were better correlated to where you'd find cracks?
And this is where I flex, and I tell you not to answer that question until we get back from the break. Audience, we will be right back, and we'll hear Cliff's thoughts on what they found in terms of most important parameters. All right, welcome back as we continue our discussion with Cliff Maier on the subject of SCC and machine learning. Terminator 1.0 might be what this episode is called, still TBD. But just to recap for the audience what we did. So Cliff Maier, which y'all did at TC, is taken a large pool of information from previous digs for SCC, where you had confirmed SCC, taken every variable that you kind of could have collected from those digs from the last 20 years, some that you suspected, some that you maybe didn't even know about, threw them at the wall to see, hey, which of these variables, when we apply like a machine learning type model, begins to identify factors that stand out. And are those factors better than the, let's maybe say, somewhat arbitrary weighting factors that we would have selected or we've been using perhaps for 20 years? So like in comparison, audience, just give you some idea. If you read 31.8S, it has a section on stress corrosion cracking, right? And it says like operating stress above 60% my soil topography, but it provides no weighting factors. Right. So you guys have taken a step further, have some weighting factors. Now the machines have risen up. They have provided us with even better weighting factors. So we think. Is that fair if I set the stage?
I think you have.
So Chris, you asked a question before break, which I completely, with the authority that was given to me as host of the show,
as Knight of Pipeline
said
Things.
we were going to a break. Would you like to ask that question again?
Sure. What predictors did you find after you guys went through the machine learning? Did you guys think were most relevant? And were you surprised?
I'll answer your second question first.
Okay.
No, we weren't surprised.
Is that surprising?
What we found were
The old guy's got it right.
what we found were that the predictors that the model was saying were most influential.
Yeah.
Actually aligned quite well with the guidance and literature that's been in the industry for years. So
Well, that's comforting, right? That kind of makes us think like whatever we've been doing is still on par, right? It's
Yes.
okay. It's not the sky is falling.
I think it's good that it's kind of it's objectively validating what our experiences have been, which I mean that's kind of what I see. So I think I'm with with Cliff, Chris. I almost say Cliff, Chris. You know, those
That the
come up really fast.
OPPs had it right.
Exactly. So
Right, the old professional pipeliners.
I wasn't gonna say it. That was
Pipeline
on
professionals.
you, man. If you wanted, we don't have an
We
OPP
gotta change.
congregation
We gotta
yet.
change it up a little bit, right? We don't want to like follow perfectly.
All right.
We had
So
it right.
just talking a little bit about top 10 machine learning predictors for SCC. Are these in rank order by any chance?
Yeah.
They are, and they're the top 10 that we found based on the data set that applies to our system. So,
Oh, it's I like
Oh,
how you
that
know how
was
he did that.
so clutch. You are a pro at this.
Wow, he totally like clarified
That's
it. It was
so
like
good.
fine print inserted.
It's
into
almost as if you'd even worked for an ILI vendor before. This is what works for our system. That was good. Keep going.
Yes,
No,
okay,
keep going. That
so-
was great.
okay,
the data asterisk only applicable for TC systems in certain circumstances when applied with the correct machine modeling and the data fed into it from 2006. Thank you. Go.
so we're talking about the top 10 predictors, and to the last point here, many of the predictors align very well with what's in the industry documentation.
Yeah.
So, for example, soil type, soil texture, operating stress level,
Yep, those are all ones definitely we know about.
Mm-hmm.
coating type, distance to nearest compressor station,
Yep.
soil topography. I'm sorry, site topography,
Mm.
the precipitation, the clay composition of the soil,
Mm.
and temperature.
So I wonder if clay's. It's interesting to theorize here, but I wonder if clay is leading to the degradation of the coating because it's so stiff around the coating and has the ability to degrade the coating. I wonder what the rationale would be, or is there a better rationale than why is clay a factor?
I think clay is a factor because it has to do with the absorption of moisture and the ability of the clay to impose stresses on the coating and its ability to degrade the coating based
So-
on the moisture.
Interesting. Just observations that I want to ask you about, if you don't mind. So it's cool. You'll have annual precipitation on here, which kind of makes sense because we know that water is a factor in corrosion. So we'd assume that in that susceptible environment, water is a factor. But then you didn't find things like groundwater or river crossings to be a factor in that. Do you think that there's anything to that, or is it just separation? Does it matter how the water actually gets to the pipe?
Well, to be honest, the couple of things that you mentioned may not have been included in the model that we considered here.
Okay.
But I will say that we did incorporate data from public data stores, which
Yeah.
could fill in some of the gaps from
Yeah.
from what TC has in our database. So we don't have all the data from our digs that
Yeah.
we would maybe consider in the model. So we had to get information from data stores.
Gotcha.
So this is publicly available information about climate. So
Yep.
we're talking about temperature and precipitation. And then also we're talking about Sergo data. So as much as we have soil characteristics from the dig information, there may be some details that we can pull from the database,
Sure.
or sorry, the publicly available store
Yep.
that maybe fill in some of those gaps as well.
Okay.
And in fairness, these are just the top 10, not necessarily all of them.
That's correct.
And I think just as a reminder, you
We're
did
not
say,
sharing the other 10, even
Yeah.
though they're only applicable for their system.
Yeah, but
That's proprietary.
but obviously the
Joking.
the idea is to some degree these are almost weighted, right? So for example, if you were to say soil texture was the top rank, that probably you're saying compared to the 10th one, it's significantly higher weighted for an SEC predictor. Is that correct?
I think that's correct. Yes. So the ranking is really based on looking at multiple models, and the more significant a parameter is for all the models, the higher it ranks in the list.
Oh, that makes us ask. You said models, not model. What's that about?
So in the development of the model we ended up using, we tested various types of models.
Okay.
So there's more than one machine learning model that's out there, or more than one method. And so
There's
we
a
can
T100, there's a T0, there's the liquid guy.
we can see the
Cliff went right past it.
oh, sorry.
No, get to it. Get to it. Yeah, so there's multiple
But,
models.
but we can evaluate the different model types and see which ones give us the best predictions.
Gotcha. So and let's talk about that. How did you judge best predictions? Because now I'm curious about that. So you've developed these weighting factors. You've listed them here. They're not necessarily completely different than what we knew. How did you determine which model is or isn't best?
Right. So for machine learning models, there are different metrics that are used to evaluate the efficacy or the predictability of the model. How good does the model predict against the test data? So where we actually found cracking, how much of the time were the predictions correct?
Yep.
So these metrics would include accuracy, sensitivity, and specificity. So bottom line is we're above 85% on all of these metrics, which says that the model is very good at predicting and can be reliable.
So let me be clear though. So you had 2,000 data points. Did you had a separate data set that you tested it against?
So of the 2,000 data points, we split it into
training
and
test.
Yes,
Gotcha.
a training data set and a testing data set. Exactly.
Out of curiosity, was that a one-time split, or did you test it like numerous different ways? Like, let me train it on this portion of a data set and test against this, split it differently, train on this, test against that, split it again differently, train on this, test against that.
We tested a couple different ways. I wouldn't say it was very extensive, but we did test a couple different ways to see what the most appropriate breakdown was. Yeah. And for us, it made sense that the EMAT digs information or the records from that would comprise the test data set. And we would learn based on all the other dig data sets.
Got you. So now that you've gotten the rankings, you've shown that at least in the simulations, it appears to be good. Where are y'all going from here? When are you planning on rolling this out in real world trials? Or how are you planning on doing that?
Well, right now we're actively looking at applying the model to our DA or direct assessment program for SCC. So
for this year coming up?
It's a little bit late. It's a little bit late for the 2025 digs, but moving forward, we're going to use it for the next cycle, and we think that that's going to help us select the digs.
We need to set an Outlook reminder and ask him in
Are you gonna,
2026.
is there going to be IPC follow-up paper? Should we expect to hear more from Cliff on this subject?
I think there could be a part 2. Okay. I think there could be a part 2.
And so when you do this, do you envision, because right now you'll have a selection process. Do you envision like relying on that, but then saying, hey, here's 2 or 3 other digs that the model suggests might be places we should go look, and you're going to incorporate those? Or are you just going to wholesale jump ship and go to the new weighting system?
I think it's possible if the model is directing us to a location that maybe wasn't our first choice, maybe we'll consider additional digs just to validate that, right?
I mean, but it's got to be fun, right? I mean, you go through this whole effort, and when you get to what I'm going to call the performance of it, you're getting near 90%. I mean, that's got to be pretty exciting, right? You're like, man, this is a good project. We did well.
Well, that's very exciting. And we think the model is very applicable to something like direct assessment where we can pick a dig site. However, when we consider something like EMAT digs, it would be nice to use the machine learning in that regard.
To incorporate that as a data set to make also increase performance of your hit rate on EMAT digs.
Exactly. At this point, though, I think it's probably best to use it to gauge expectations for what we might find, as opposed to influencing the decision making on whether to excavate.
That is a great point.
I like that.
That is a great point.
Say it again.
Have the EMAT signal. You can't necessarily be fully biased because this machine learning is saying, hey, all the predictors aren't there. You're like, I'll consider it, but I'm still going to make sure I'm verifying or validating the EMAT results.
Yes, and we know that
at least at this level of maturity, right?
True.
Yeah.
And we know the model is pretty good, but it's not perfect. So there are still cases where the model might say there's no SCC, but maybe we found SCC. So
none of the DA models are perfect, right? So you
it feels like a win. So I would ask this. Maybe like if there were other operators or others trying to go in this effort, any lessons learned, anything that you were like, yeah, this was really important that we figured out in this process?
Well, I think it illustrates for the industry that machine learning is definitely a legitimate approach that can be used to help manage SCC or any other threats.
Yeah.
So in this case, we applied it to SCC, obviously, but it can be used to manage other threats as well.
And there you go. So you're opening the door. I think this is a good topic to close in on. You're saying other threats. Do you have ideas? I mean, are y'all thinking about maybe non-axial cracking, or Where do you kind of see this going in the future, Cliff? Beyond testing it, are you all going to try this on other threats, you think?
It's possible. I'm not the decision maker there, but I
Do
can.
you
I'm
want to
thinking
do
walk
it?
before you
In your
crawl
spare
before you walk,
time, are
right?
you
I think we'll definitely share this, the learnings here with
Yeah.
other threat teams,
Yeah.
and we'll see where it goes.
I mean, if it works for axial SCC, I mean, it seems logical that you might extend it to circumferential SCC, for instance.
we're looking at that as well.
So you are doing it. See, I knew it. He was
Ooh.
trying to.
We're
He
looking
was
at
keep
that.
digging,
Is
keep
doing
digging,
it.
right? Keep digging.
Yes, circumferential SCC, maybe using it to prioritize segments for EMAT inspections.
Yep.
Oh, now that's I
Yeah.
like that, prioritizing
Yeah.
segments for
Keep
EMAT
digging.
inspections.
Keep digging. You're doing well.
Yeah.
I'll give you
So-
one more.
Oh.
Give me one more.
Validating risk results.
Yes.
Oh, that implies that you did a risk assessment
Yeah.
first. So
Sure.
I'm just joking.
Yeah, but that's
That's
good.
Chris and I's like.
But that's good.
One of Chris's like trigger points, right? Is performing risk assessments. So, well, hey, Cliff, I want to say thanks for joining us. I look forward to seeing where y'all go. I hope there is a part 2. If you need help with the title, let me know. I'm happy to do it. So that was Judgment Day. That could be it. Machine Learning, Judgment Day,
Day.
results of the assessment. See, I've given you the name of the paper.
There
I
it
look
is.
forward
That is
to it
so
at
good.
IPC.
There it
IPC
is.
2026.
Look, you know what's
You
good,
heard
Miss
it here
Producer,
first.
Don't lie, and then just give me props. Like when you give a presentation, I like to thank.
Don't
Greg
give
Dodson for the
him
clever
props.
product.
Do not do
Yes,
it.
Absolutely. Well, hey, thank you for joining us. We appreciate it. To our audience, thank you. Hopefully, we got to see you at PPIM. If we don't, there have been some great papers, and hope we catch you around. Thanks for joining us on this episode of Pipeline Things.